This is the second of two videos which looks at GCSE-type questions on expressions. In the previous video we looked at writing and interpreting expressions, evaluating expressions, and simplifying expressions. I've put a link to that video in the description below. In this video, we are going to look at expanding expressions and factorising expressions. Again, this isn't a definitive list of GCSE-type questions, but hopefully it will give you some idea of the types of questions you might face and the skills you are going to be tested on in an exam. So let's look at a couple of examples on expanding expressions. Here's the first question. Part A. Expand 2x open brackets x subtract y close brackets. Notice that there are 2 marks to this question, suggesting 2 parts to the answer. More than likely, the extra mark will have something to do with simplifying. Now, when we are being asked to expand an expression, the chances are that the expression is in factorised form. To briefly explain what this means, let's look at prime factors. The prime factors of 6 are 2 and 3, and when multiplied together, they make 6. For 70, the factors are 2, 5 and 7, and when they are multiplied together, they make 70. And for 12, this is 2 multiplied by 2 multiplied by 3, or 2 squared multiplied by 3. In each case, we are representing these numbers in factorised form by multiplying the factors together. If we look at this expression here, it's in factorised form. It's saying 2x multiplied by x subtract y, where the 2 factors of the expression are 2x and x subtract y. And by multiplying these together, we will find the expanded expression for which 2x and x subtract y are factors. To expand this expression, I'm going to multiply what's in the bracket by 2x. So that's 2x multiplied by x, subtract 2x multiplied by y. That step will give you a mark. But there are 2 marks on offer. This is because we can simplify this answer. 2x multiplied by x is equal to 2x squared. Subtract 2x multiplied by y, which is 2xy. And there's the answer. So the expression for which 2x and x subtract y are factors is 2x squared subtract 2xy. And that answer will give you 2 marks. Part B, expand and simplify x add 3, x subtract 2. Here you are prompted to simplify your answer to get the 2 marks. So what the question is asking is, find the expression for which x add 3 and x subtract 2 are factors. Here's the approach we use for expanding 2 brackets that are multiplied together. This is a standard approach which you need to learn when multiplying 2 bracketed expressions together. We do x multiplied by x, which is x squared. Then we do x multiplied by minus 2, which is minus 2x. Then we do 3 multiplied by x, which is 3x. And finally, 3 multiplied by minus 2, which is equal to minus 6. This stage will give you 1 mark. But this can be simplified. We have x squared. Then we have minus 2x add 3x, which is equal to x. Subtract 6. And that's the final answer for 2 marks. X squared add x, subtract 6. Let's look at another question. Part A. Expand and simplify x multiplied by x add 4 multiplied by x subtract 3. There are 3 marks because there is more work involved here. In the previous question we were multiplying 2 terms or expressions together. This time there are 3. The way I would tackle this is to expand the bracketed expressions first of all, using the same approach used in part B of the previous question. I'll begin with x open brackets. Now we're going to expand x add 4 multiplied by x subtract 3. That's x multiplied by x, which is x squared. Then we have x multiplied by minus 3, which is minus 3x. 4 multiplied by x, which is equal to 4x. And then we have 4 multiplied by minus 3, which is minus 12. And then we close the brackets. This will give you 1 mark to show that you have started on the correct path. But there are 2 more marks on offer, and we haven't finished answering the question. We can simplify this to x open brackets, x squared, add x, subtract 12, close brackets. The simplifying of this expression will give you another mark. Now we multiply through by x. That's x cubed, add x squared, subtract 12x. And there's the answer. So this expression is made up of the factors x, x add 4, and x subtract 3. And this will give you the final mark. Part B, expand and simplify y add 2 multiplied by y add 4 multiplied by y add 1. How I would tackle this is expand 2 of the brackets first of all. And I'm going to expand y add 2 multiplied by y add 4 as they happen to be the first 2 bracketed expressions. I'll begin by writing down y add 1, as I'm not going to do anything with this for the time being. Now let's expand the other 2 brackets. Y multiplied by y is equal to y squared. Y multiplied by 4 is equal to 4y. 2 multiplied by y is 2y. And 2 multiplied by 4 is equal to 8. Let's simplify this. So we have y add 1 multiplied by y squared add 6y add 8. And that will give you 1 mark. The next stage is to expand these brackets. Well, let's do that. We'll begin by multiplying through by y. Y multiplied by y squared is equal to y cubed. Y multiplied by 6y is equal to 6y squared. And y multiplied by 8 is equal to 8y. We are then going to multiply through by 1, which will basically be y squared add 6y add 8. So we have y cubed add 6y squared add 8y add y squared add 6y add 8. And this will give you 1 mark. Again, this can be simplified. And this simplifies to y cubed add 7y squared add 14y add 8. And that's the answer for 3 marks. So this expression has the factors y add 2, y add 4, and y add 1. So that's expanding expressions. Now let's look at factorising expressions. Here's the first question. Factorise 3x, add 3xy. There are 2 marks. Factorising is essentially the opposite to expanding. Think of this expression as being in expanded form. And what we are being asked to do is rewrite this expression in terms of its factors multiplied together. So let's have a look at 3x add 3xy. Hopefully you can see that 3 goes into both terms. We have 3 lots of x and we have 3 lots of xy. So we could rewrite this as 3 open brackets x add xy close brackets, which means 3 lots of x add xy. We have written this expression as a multiplication of the factors 3 and x add xy, and that would give you a mark. But for both marks, you should have spotted that x also goes into both terms. This means that we can write this expression as 3x open brackets 1 add y close brackets. That will give you both marks. So by factorising 3x add 3xy, we have written it in terms of its factors 3x and 1 add y. Part B. Factorise 8a squared add 4ab. Looking at the coefficients, I can see that 4 goes into both terms. 4 goes into 8 and 4 goes into 4. I can also see that for both terms, a goes into them. We have a squared here and we have a here. So 4a goes into both terms. 4a goes into 8a squared and 4ab. So to factorise this expression, we have 4a open bracket. Now 8a squared divided by 4a is equal to 2a. Then we write down the add. And then we have 4ab divided by 4a, which is equal to b. And we close the bracket. So the answer is 4a open bracket 2a add b close bracket. And this answer will give you 2 marks. If you had just divided through by 4, for example, you would have ended up with 4 open bracket 2a squared add ab close bracket. And that would give you a mark. But you wouldn't get 4 marks as you could factorise this further. So for the 4 marks, you need to have spotted 4a going into both terms. Here's the last question. Part A. Factorise 9x squared subtract y squared. Now whenever I see a question like this, where there are 2 terms, one being subtracted from the other, and there are variables that are to the power of 2, I'm immediately thinking of the difference of 2 squares. Here's a brief overview of what I mean, but I will look at this in more detail in a future video. Here are some factorised expressions that have been expanded. What do you notice about the expressions in factorised form and their respective expanded forms? Starting with x add y, x subtract y. Notice that the difference between the 2 bracketed expressions is the sign. We have a plus here and a minus here. Now look at the resultant expanded expression. We have x squared subtract y squared. We have one term squared subtract another term all squared. The difference of 2 squares. The word difference refers to the subtraction. And notice the relationship between the squared terms and the terms in the brackets. we have x here and x squared here, y here and y squared here. For 2x add 3, 2x minus 3. For 2x add 3, 2x subtract 3, notice that in the brackets, the difference between the expressions is the sign. We have a plus here and a minus here. The two terms are the same. And the resulted expanded expression is a difference of 2 squares. 2x all squared, subtract 3 squared. And notice the relationship between the squared terms and the terms in the brackets. We have 2x here and 2x all squared here. We have 3 here and 3 squared here. And let's look at one more. We have 5x add 3y, 5x subtract 3y. The difference between the expressions in the brackets is the sign. The expanded expression is again the difference of 2 squares. 5x all squared, subtract 3y all squared. And notice the relationship between the squared terms here and the bracketed terms here. So that's 5x, and then we have 5x all squared, and we have 3y and 3y all squared. Working the other way round, and this is where question 2 comes in, we are factorising expressions that contain the difference of 2 squares. And if we can spot that it's a difference of 2 squares, then we can easily write the expression in factorised form. Looking at x squared subtract y squared again, I can see that this is the difference of 2 squares. So I know I'm going to end up with 2 brackets, and it's going to be something add something, something subtract something. And we know that those somethings are going to be these terms, x and y. So we have x add y, x subtract y. And there's our factorised expression for x squared subtract y squared. Let's look at some other examples. Here we have x squared subtract 9. 9 is a square number. So we can write this as 3 squared. We have now written this expression as the difference of 2 squares. And so we can write this as something add something, something subtract something. And those somethings are the terms here, x and 3. So that's x add 3, x subtract 3. And let's look at one more example before we go back to the question. Here's 16x squared subtract 49y squared. Both 16 and 49 are square numbers. So we can rewrite this expression as 4x all squared subtract 7y all squared. We now have the difference of 2 squares. So we can write this in the form something add something, something subtract something. And those somethings are these two terms here, 4x and 7y. So in factorised form, this expression is 4x add 7y, 4x subtract 7y. As I've mentioned before, I will do a future video on this. But let's take what I've just shown you and apply it to part A of the question. Factorise 9x squared subtract y squared. As I mentioned earlier, whenever I see a question like this, where there are two terms, one being subtracted from the other, and where the variables are to the power of 2, I'm thinking of the difference of 2 squares. So let's rewrite this expression as the difference of two squares. The coefficient of x squared is 9. 9 is a square number. I can therefore rewrite this expression as 3x all squared subtract y squared. We now have the difference of two squares. So our answer in factorised form is going to be something add something, something subtract something. And those somethings are going to be these two terms here, 3x and y. So we have 3x add y, 3x subtract y, and that will give you 2 marks. For part B, notice that both coefficients are square numbers. 25 is 5 squared and 4 is 2 squared. So we can rewrite this as 5x all squared subtract 2y all squared. This is the difference of two squares. So we can write this as something add something, something subtract something. And those somethings are 5x here and 2y here. So our answer is 5x add 2y, 5x subtract 2y. So in the examples covered in this video, expanding and factorising appear to do the opposite. If you are being asked to expand an expression, the chances are that the expression is currently in factorised form, and by expanding, you are multiplying out those factors. And when writing an expression in factorised form, you are rewriting the expression as a multiplication of its factors, which might include constants, variables, and bracketed expressions. I will look at this in more detail in a future video. But in the meantime, I hope you found the video helpful. Don't forget to like and subscribe, and thank you for watching.